Welcome to the Databricks Skill Builder series. We're glad you're here.
Hey everyone, Arthur Dooner, Specialist Architect Databricks, here to talk about the information extraction technology in Databricks powered by our new Agent Bricks. Agent Bricks are a suite of foundational AI technologies that we've enabled in the platform to help a lot of different users build insights out of their unstructured data, from being able to converse with the data as a knowledge assistant to being able to create custom actions, maybe broad summaries about unstructured documents with the technology, the agent brick um, custom LLM, to what we're going to be focusing on today, the information extraction brick. We've got a lot to learn in a short time, and I wanted to dive in with y'all today to try to figure out how we can parse out these documents together, okay? And I've got a fun use case for y'all. I've scanned in all of the receipts that I have from different home improvement and plant stores, gardening stores, and I want to see the different types of plants that my girlfriend and I buy on a regular basis, and kind of get a sense from those documents. So there's a few things working against me, right? Maybe I'll pull up a diagram just to kind of show you what this architecture will look like, but it's kind of representative of a real world thing. I need to extract a lot from these structured docs, understand some core themes, core plants, right? So let's talk about, we've got this document corpus. They're very inconsistently structured. So we can think about, they could be from a lot of home improvement stores. You could think like things like Lowe's. You can think Home Depot, Ace Hardware. All those have like plants and plant supplies. Similarly, there are other places that we might think about, like, gardening stores, right? Like there's a few different gardening stores. There's this one that we used to love to go to in Ohio, um, called Groovy Plants Ranch. Um, but I've got this collection of all these receipts from all these different places, from like home improvement stores, gardening stores, and I want a broad idea of what types of plants we've been buying, right, in the past few years. So all of these, I had my physical scanner go and scan these in, and now I've got a bunch of PDFs of that need to be OCR'd, right? So we don't have, or maybe we should say lacking OCR, right? And there's a foundational technology that bridges us from these unstructured PDFs, right, into a parsed out piece of content that we can human read, and then we need to extract the entities from, right? So we need to figure out, like, how do we parse these docs, right? And then actually, how do we extract entities? And then there's really another analysis that kind of follows this. Like, once we've extracted the entities, we need some sort of summarization or like output to tell me about all of these different documents, all these documents, all these plants that I've been buying, and what sort of plants I might have purchased, right? Um, so we have to do all four things in the next 30-ish minutes. So what we're going to do, there's this technology that we're going to start with called parse document. What AI parse document does, if you check out real quick, um, AI parse document, Databricks, and I'm intentionally showing some like of publicly available sources so you'd be able to follow along in the same way. AI parse document takes any arbitrary PDF and gives us a bunch of content with the output results from that doc. Okay? So first, I need to go and load in a bunch of assets that we can then read together, right, into what's called a Databricks volume. Volume's just an unstructured data location, kind of like an S3 bucket location. Then we can say object storage. Then we can parse those documents. Then we can use the technology is called information extraction. So I'm going to highlight this in red because red means Databricks, right? Information extraction capability to extract the entities out of this document. And then we need to have some sort of summary or takeaway about all the plants I've been buying. From here, this is where I will switch over to some code, right? And I intentionally have not made any code assets or data assets as we get started. So first, I'm going to make a schema, and we're going to call it Arthur Plants. I guess that's kind of redundant because I already have a catalog named Arthur Dooner. So let's say plants. And people are going to be very confused when they look at my catalog in the future. Like, what's he got in here? So I'm going to have this volume of receipts of the things that I've purchased. And now I have this folder that I can upload things to. Obviously, production processes might be fed by something, right? Served and captured by some other entity that feeds in these receipts from my scanner over the internet more brilliantly. But today, we're being lazy. We're just copying those files from my downloads. So give me one quick second, and I will find those receipts, and we're going to go and parse out all these entities in a second. So give me one second. I'm just going to my documents, my receipts, and we're going to start with, how about we go to home improvement, which is a place that I go, and I'm intentionally including some amount of purchases that are not plants, right? There's a folder full of all of this content. I want to understand where are my plants, right? So I'm going to upload all these, right? Maybe I'll make a new folder, receipts, Arthur, and yep, there's the directory. And these are like the receipts that I personally uh, I have received, and then my girlfriend has the same thing, the places that she's gone and purchased plants as well, and maybe home improvement things as well. So here we go. We're going to refresh this page. We're going to see, oh, it's still uploading. Okay, I'm going to just upload a few more as we go, and we're going to say here's Hannah, and we're going to upload some of her receipts and browse. Yep, I can even use the Databricks platform. And I go to people and documents, receipts. Yep. And I think I've got a category just for plants. Yeah. Okay, cool. So these are a little bit more plant focused. And did I actually call it the folder, Hannah? Okay, cool. So now we've got all of these other PDFs. Just to give you an idea of what some of these PDFs might look like. That was not seamless. Can I download it and then view it in the browser? Yeah, so like this is what it looks like. It's all this like messy, and you can see like there's a succulent, right? Oh wow, is it OCR? That's kind of fascinating. I don't think my printer usually does that. But either way, it's kind of a mess, and I want the AI document parse to parse it out anyway. So, and I don't think all of them are that clean, so we can just quickly look at a few others. If I go to, yeah, like Weston Nurseries is like a more recent thing, and I download and I say click. And okay, it is recognizing some amount of text, but interpreting like these things as tables, is not going to be trivial, right? And there's going to be a lot of other garbage that's out here that we want to parse. So let's first, we've got these receipts, right? There's a huge different variety of, Lowe's, Home Depot, Ace, Weston Nurseries, like random small shops that we've been to over the years, right? So now we have to think about, let's go and extract these entities together. So we've got this plant receipt folder, and let's go to copy this path. So you can see receipts copied that path, right? And I think it uploaded everything. And even if it didn't, we've got a complete enough set. And I'm going to say I want to do AI document parse. And so I go back to the AI document parse page, that documentation that I've got up. And I'm actually going to run it. I was working on this with a customer earlier. It was actually a really clever way that we approach this. Yeah. So this is what we're going to do in Python. See how it reads in a binary file, which is just our way of saying, like, this is a PDF that we do not understand or know how to parse, right? We load it from a directory. We say, this is the new column that we're making, and this is the function that we're calling. Okay? So what we do is we go back to this notebook, paste all this in. I'm going to copy this directory here, and we've got a load step. And oh, I I need the path. Yep, so right here, down here. Um, we say it's going to look like this. And I need to add two things. I need to add a recursive lookup and a path glob filter. Path glob filter is saying I only want to look at PDFs in case you've got a lot of different types. And recursive lookup means all the subfolders. Um, add recursive and glob filter. And the assistant's going to know exactly what I mean. It did. This is what happens when you use Spark for 8 years. You know these crazy things. So now we've selected just the recursive files, so like all the subfolders, Arthur and Hannah, and then the glob filter, which is saying all PDFs against this folder. We're going to parse an AI parse document, and I've got a serverless cluster. If I go to the configuration, this blew my mind the other day. Um, you can do, there's a new third environment version that I didn't even know about. So this should have the dependency for AI parse document, but my customer hit this earlier today where it didn't, and we can just call, like, we can wrap it in like an EXPR. This, I promise that didn't take us 20 minutes. It did. But our time loss is accelerated today. So it's probably going to complain. Let's double check that. But that is, now we've made this data frame. We're parsing these documents. And actually, before I run this, shouldn't have done that. I want to say df dot limit 1. I think that's right. Do I know how to run? It's going to be like, I don't know what AI parse document is. It's too new of a function to be included in the Spark APIs yet. Yep. So what we have to do is we have to say wrap the AI parse document in EXPR. Yeah, something like that. So you see, it's basically running it as if it's like a sub command in SQL, where it's the SQL, these functions are universally registered, and we can see that it parses out one, limited to one receipt. This might take a minute, depending on like how available these functions are. What I'm going to do is I'm going to scaffold the rest of this pipeline for us to be able to save this, all of these records. I'm probably going to limit it to about 10. And then we'll say, okay, then we need to extract and clean up these entities. So I need to figure out, like, how do I get just the text out of this doc? And you can see the results are too large because we're reading this binary file. It's not going to display anything. You'll be like, what, did something break? No, it worked fine. It's just in my example here, I included the results of the binary file. So it's this huge, long, icky text that's like the raw PDF as one of the columns. So what I'm going to say is, I'm going to say df dot, I don't care about this binary file anymore in this case. I'm going to say df dot drop, what's the name of it? It's, the column would be content, which is binary, right? And then that content becomes, and then I say write save as table, right? And this is now, we've got this key piece. We're going to call it Arthur Dooner plants, and it's receipts parsed, right? And we are going to, I think we can say limit 10. I think it works that way. Let's find out. All right, so we're only going to run 10 receipts. I always encourage when you're proving this prototype first, you don't run it against your entire data corpus, right? And with this AI parse document step, always, make sure you save the results right after, because Spark is lazily evaluated. It will only run these pieces in, oh, like over and over and over again if you like lose memory or you save some on their data frame. So it might not always preserve those things in memory. So save that to a table or to a disk such that you prevent yourself from accidentally running this process a billion times and being like, why do I have this crazy AI parse charge, having run it a bunch? So now I'm going to load that table back in, which means I'm never going to run the AI document parse again. Now I say df equals df parse. We'll just say equals spark.table, and we'll read that table back in. And that's where we can do some of the cleanup on the structure of the table, and maybe we can see some of the outputs. That's going to save us some time. We can see a display df parsed. So as you can see, this one's almost done. So we're going to give that a second. This one's just going to run the second that one's done. And then there's going to be this whole structure of the AI parse document that I want to extract from. But right now, I only care about like one field. And I believe it is. So if we look at some of these outputs, yeah. So see how it's go. Documents, pages, elements, corrupted data, error status, metadata. So I care about the contents of these pages, right? So I'm going to be pulling out all of the pages and all of their contents. That's all I care about. I believe in the context of a receipt, I'm only going to need the 0th page, because I believe if I'm smart, I structured every receipt to be one page. And I don't think I have very many, if any, multi-page receipts. So let's hop on over to, okay, so this is almost done. Let's just, we've saved this table, right? We've got this parse column. The only thing that let's approach information extraction and see if it complains. So if we go to information extraction, we go to agents and we say, see how it gives you an option to use PDFs? That's just going to try to give us a folder in advance. This might take away some of the flexibility. So I'm going to try this in a second to show you how this easily allows you to approach this workflow, right? But personally, we're going to start with just a pre-existing text data that we have. So as you can see, Arthur Dooner, plants, receipts. Oh, I've got too many plants things. Plants, receipts parsed. Yep, use this table, and we can select the column, and it's like, oh, yep, parsed is a variant type. We can't use it. So in this case, I'm just going to simplify this output, and we're going to say, just for the time being, clean up cast df parse to df parse to what's the variant type parsed to string, because it will be able to extract those sorts of entities, right? So here we go. This is a with column cast except great display. Right now we've just got this as like a long crazy string. Kind of messy, but that's okay, and AI can handle that. Then what we can say is take this out, save this to a stringified version of the output table. Apologies for the typos. Okay, yep, there we go. There we've got stringified. That should work. It should be really quick. It is really quick. And now we can go back to Databricks, and now I can change this. Probably gonna have to refresh the page. Oh, faster, better. Now we've got parsed. Now, this is where it gets fun. Look at that! It even pre-generated examples for us. Is that not insightful? So it's trying to understand like what are some information about these transactions and things. And I don't I don't want to extract like what type of payment I made, right? But as you can see, if you're trying to extract metadata about customer transactions, that's the way we might approach this information extraction, right? So we could now instead say, I don't really care about transaction details, but I do care about um maybe like plants mentioned, true, Pythonic true, grumpy. I think, oh, it's that true. It's not Pythonic true, it's JSON true. And then we can say plant types. Um, and if we look at a receipt, we could maybe say it's succulent, right? It could be I need double quotes. Rookie mistakes today, guys. Succulent, what's another one? Monstera, uh, bird of paradise, or maybe um plant type succulent monstera might be a good first level filter, right? And we might have a secondary plant, uh, what's the word? Like species, if it's very specific. Sometimes it is. We might not always have this, right? Um, Plant species could be, what's the name of it? Like a bird of paradise, um, Monstera high constellation. I think I'm probably spelling these things wrong. And I'm not the plant expert. I'm just plant intrigued. Okay, there we go. Now we've got an example. You can see I do kind of like that we have some of the items purchased that might help us tell the story a little bit more cleanly than like extracting these plant types and species. As I approach information extraction tasks, I'm going to maybe try to parse out the entities a few different ways, right? Oh, maybe it might best format as articles and reference records. Maybe it's going to best format as types and species, right? In this plant example, right? But I'm going to call this plant extractions. Um, Plant type and species extractions from receipts. Now we can say create this agent. So this will take a few minutes. And when I say a few minutes, I'm hoping a few seconds here. And what's going to happen is it's going to generate some key records that are going to make our lives easier, to help us validate the approach, make sure it's extracting entities as we would expect, and it would show us a few key examples. Sometimes these agents take a few seconds to build. So as you think about these receipts, right, you might format yours. Receipts are just one type of problem. It could be big, long documents that you're trying to extract topics out of, extract keywords, extract entities and relationships out of. This is not just for these like simple AI solutions. These are for helping you layer in the context and the topic relevance such that you can filter, both your AI systems that you build later on, like in a vector search, to better target, hey, I'm looking at receipts just from IKEA when I give an analysis of my IKEA spend. Or on the other side, you could build these into reports based on those like predefined entities that you've extracted to help you identify, hey, these are all the breadth of the types of reports that are the types of plants that we buy, right? And now you can see it gives us opportunities to improve the instructions. Like, you are always looking for plants. Plants are everything to you. We want to focus on finding only items at stores that are plants that we care about. Um, Make sure to list out all of the items we buy that are plants, and if possible, include plant type and species. And you can see what this is including is all of these different fields that we kind of prototype together. So you can see like the store location, the items purchased, items article, that sort of stuff, right? Any sort of plants mentioned, like, hey, do we even talk about plants? Um, what plants are there? What species might be relevant? Like common names, botanical names. I like how it gave us that flexibility. As you can see, I didn't do any of this. You can change the types. It's presuming what I'm intending by the content of my documents and the not just and the format in which I recommended the structure for. So I can update this agent. So give it a second. Now it's probably going to not capture any items that are maybe it would focus less on capturing items that are not plants. Now, what's interesting is that at the top of these information extraction workflows, it provides recommendations for the best next step to improve system quality. It recommends add more context about plant types. That's a little vague, right? Add some instructions so that the AI system is very focused, right? You can see it's saying like, oh, doesn't look like this has any plants. Quite bad, right? And then in contrast, right, here's one. There's a plant, right? So I've refocused my agent towards just extracting plants, which I love. Which, as you can see, has had some knock-on effects of maybe not telling me about other items, which might be what I care about, and like the total amount is still captured, but maybe not super relevant. But it gives you recommendations on like how do you want this? Do you want it to be structured a guaranteed way? What's the currency, right? What's the plant species, right? Clarifying what we mean. Are we looking for a certain taxonomy? I'm not yet. I want to see what this thing can even generate, right? So I'm going to so I've got all this full text, as you can see. Um, so a lot of these in this case are empty. So now I've built a very simple prototype, and now I could go and try to use this. So I could go to start these extractions across my documents. So what I'm going to do now is, now that I've like proven out the case that it looks like I'm going to be able to extract some plants here, um, what I'm going to do is I'm going to go back to my parse document function, the script that I wrote, and you see how earlier I limited it to 10. Where's my limit? It was, yeah, limit 10. I'm going to unlimit it. This will likely take a longer frame of time, right? But maybe we'll just start and we'll say like limit 50. That way we're not here all day, but we can get a much broader sense of the plants that I've been purchasing. Um, we can run this. We're going to run this. We have to overwrite. Oh, that's not going to run. We have to say write.mode overwrite. Everyone misses this. You're all, like, I'll do a working session with someone and like, oh, it worked the first time. And then like, why doesn't it work anymore? Um, so this will take a little bit, and then we'll go and read this parse table back in. And then we will cast to string because we're super lazy and we haven't extracted any of the entities because it's not the focus of our time today. We have to overwrite that again. Overwrite, mode overwrite, sorry. And now we're going to save this as a table. So what we've seen is now we have a way to extract key entities that we care about, and then we can run it across all of our data. We're going to give this a few minutes to run. I'm sure it will take a little bit. And I want to tee up a few other pieces. So now you can see, as I think about scaling this, right, it gives me an example AI query to run across a lot of different documents. So really everything you just saw in that, let me just go back to it real quick. The agent that I made, the plant type and species extraction from receipts. This agent is just focused on building the agent. Okay? It isn't focused on, this view is focused on building the agent. And then later we can review the inputs and outputs it created so we can evaluate and optimize and improve it later. that would make for a part 2 on this topic as you're improving system quality. But for now, all you do is you use it. You say, let's start this extraction, and it generates this query, right, with that new generated endpoint across my stringified table. And we're going to run it. Let's run it against 50, right? And this should lead to us having that table generated that we can go and save these results. So it's going to take a second because this is still running. But once we have that endpoint and once we have this data, we can run this query. We're running the AI batch inference, that is our information extraction pipeline, at a much bigger scale. And now we can, this is effectively the most efficient, cleanest, and simplest way to both get AI system results from all these entities, but also, as you can see on that other page I was showing you, we can eventually, with more data, we can optimize this model so that it will cost less to generate these results. Or you can schedule a pipeline that will automatically run against new receipts that come in every day, right? So the path to integrating AI into data engineering for these example information extraction tasks is so clear and evident. Finally, as we looked at, maybe I'll drag my diagram over. Where's my diagram? Oh, I'm looking at it. There you go. So we've already done all of the loading here. Maybe green for good. We've parsed the documents, right? And I showed you how to do it manually. However, there is a more guided tour way of doing this as well. So if I had went and made a brand new agent, you can click Use PDFs, and it will create a new workflow to process those PDFs and run that same code that I was talking about, the AI parse document under the hood, right? And you would have had to make like a schema, right? Then once you've run this, you can say, I have these 3 pieces, and we've run the volume, we've run the parse document, and we've kind of like, we've only done like the build and test. We then have to do the actual run across all of my documents. And I'm being lazy and just saying 50 for now, right? Pretending my entire receipt corpus of plants is 50, but that's not the case. I have more. Uh, Run against all docs with information extraction, right? And then we need, like in my example, I want to have some sort of summary at the end. Like, hey, what are the plants that Arthur bought, right? Why do these all matter? What's the takeaway? So with these plants, we're going to hop on over to, okay, it did run. It looks like it's saved. Looks like everything is saved. Looks like we're good to go. Yep. So now we've got all of these files. Yeah, plenty of different like botanical shops, a place called Thirst for Succulents, all these different places. And now I can run this AI query endpoint. And it's going to run against all 50, and it's going to try to extract all of these entities. And I might be shooting myself in the foot when I say this, but we're going to be very impressed with how fast this whole pipeline is, because it's a relatively optimized pipeline running on a relatively smaller language model that's focused on this extraction task. The last piece of information extraction that I want to highlight is that as you provide it feedback and guidance, it improves the underlying model's performance. So it refocuses the model to approach these problems in different and new ways as you give feedback to it. A lot of places talk about the model learns, but this is this is a place where it actually happens. And this is highly differentiated technology in the industry. Look at that. Fast. We parsed out 50 that quickly. So we have this input and response, and you can see no plants, nothing mentioned. But as we get down further, we can see this Daphne. I don't know what a linear plant is. Um, you can see a lot of like these calatheas, right? It's saving them, right? It's working. So can I save this to a table in the Databricks UI? Create custom table. Nice. Um, Save. Okay, that was a visual. That wasn't helpful. I need to save that. I should just run this in the notebook so you can kind of see what this looks like. I don't really care about. Okay, yeah, I guess that's fine. I'll copy the whole thing over. And I'll go back to this notebook just for continuity of our pipeline. And I'll say, I'm going to say spark.sql, this, I need triple quotes, right? And I'm going to say parse doc, parsed plants equals this. I'm going to save parsed plants to a new table. There we go. So now we've got to save as table step. Um, it remembered my mode overwrite thing. That's nice. And so now I'm going to save these parse plants out to a file. It's going to use that same information extraction endpoint. I'm running it again because, again, I wanted to show testing it. Oh, this works. I can try it in AI, in the SQL playground, and then I can run it back into my like pipeline or notebook that I'm building. Finally, I probably want to ask like what sort of plants are we buying, right? Um, where I'm going to take this is we're going to be a little bit playful, and we're going to see if this might not be the perfect tool for the job, but it's definitely the way I'm going to get an answer fastest. I'm going to go over to Genie, and I'm going to say, hey, I've got these plants, and we're going to wait for this to save. And whenever this actually saves, we're actually going to run, and we're going to see this new table come up like parse plants, and we're going to ask it like, hey, what sort of plants is Arthur buying, right? And then we'll have this perspective on these are the different types of plants we've been buying in the past. I think I've started taking records of this 4 years ago. So in the past 4 years, which is just kind of fun. Now we have an answer to the question that we posed at the beginning. What plants are we buying? Let's tell me about them. So we're waiting again for this pipeline. It's almost done. I'm going to say almost, I mean half. Um, so recap, information extraction, extremely powerful way, extremely fast way of repeating an action, an activity, of getting intense summaries, insights about our data. And it's a new space in AI. It's AI engineering. So it's helping data engineering be faster, get more out of these documents with AI. And where I take this, refresh, parse plants, right? Got this Genie room. Tell me about my which plants are here. Let's see if Genie gets us an answer. All right, so obviously it generated a query about the input and it didn't get the output. Yay! Okay, so I could again be very lazy. What I will later do in a part two, as we think about improving the system, is I would pull all of these results, and I would say, oh, it was wrong here. We can evaluate it more there. We can run it against a bigger corpus. And then what I would say instead is maybe I just care about um, can I change this? Yeah. Output, I think it was called, or response. I can run that. Yep. Okay, now we've got the response. I'm going to try to copy all of these things, and we're just going to see, let's go to a playground. Let's go to a state-of-the-art model. Let's go. That was great. That didn't work at all. Let me just download the output to. It's funny, it named the CSV. You guys couldn't see it. Like, which plants are here? It was quite funny. Um, okay, we've got this new response. I actually just want to load it in the VS Code because then I can just kind of copy all the text. Open with VS Code. Open. Yes, okay. And what's great about these language models, and I'll show you how to do this in the next one, is like we can tie them up to auto summarize these things, but we can just for now, again, as I was saying, be lazy and go to serving. We can use Sonnet 4. Uh, Tell me about what plants I have been buying. So obvious. I love live demos, but I think we made a lot of progress. Tell me about what plants I am buying. There we go. There's all our data. House plants, flowering plants, bulbs, seeds. Talks about IKEA plants as if that's a different category. So maybe a few additional prompt strategies other than tell me about plants. But I think we got to our answer. You can see how we can build these insights and from all of this unstructured data that was formerly unapproachable. I hope everyone has had a wonderful time exploring the space of plants that I've been buying in the past 4 years. I hope you all have a wonderful day.